Hi guys, today we're going to continue just to practice with our systems of linear inequalities and just singular linear inequalities and learn more about what solutions to linear inequalities truly are all about. So I am going to do number one with you. It says, which ordered pair is a solution to the linear inequality below? So in order to figure this out, we are going to graph this inequality. So remember, in order to graph an inequality or an equation, it has to be solved for slope-intercept form. So that means we have to get this y all by itself. So the first thing I'm going to do is subtract this 3x and put it on the other side. When I do that, I can't really do 10 minus 3x. So I'm going to rewrite this here. I have negative 5y is greater than or equal to, and since I can't really subtract those, I'm just going to rewrite it. I have a negative 3x and a positive 10. All right, then in order to get rid of this negative 5, I am going to have to divide everything by negative 5 because that's like negative 5 times y. So these will cancel. Because we divide it by a negative, we have to flip our sign. So it was greater than or equal to, and now it's less than or equal to. Negative 3 divided by negative 5 makes a positive 3 over 5x. And then 10 divided by negative 5 is negative 2. So I can now graph this. So remember, with graphing, we start here. This is our y-intercept. So we're going to find negative 2 on the y-axis. So it would be right there. Then we move our slope. And since it's a positive 3, that means we're going to go up 3 and right 5. So from this dot, I'm going to go up 3 and right 5. And put my next dot. And if I could go up and over again, I would, but I'm going to run out of room. I will go down 3 and left 5. We can always do the opposite. Then we have to figure out, how are we going to connect these dots? Is it going to be a dotted or a dashed line, or will it be a solid line? So we look at our inequality for this, and it's going to be solid because this line right here, that's what tells me it's solid. All right, so I'm going to connect this with a solid line. All right, the next step is to shade. It is greater than, oh, I lied. Whoopsies, we need to look down here. Sorry. I'm using the wrong one. It's less than or equal to, so less than means I shade below. Everything I just shaded is a solution. Everything. Every coordinate under there is a solution. So we just have to pick from these which one of these is in that shaded blue region. So let's check. 1, 4. That'd be right 1 and up 1, 2, 3, 4. Is that in that shaded region? No. What about 6, negative 3? 1, 2, 3, 4, 5, 6. Down 1, 2, 3. Look at that. It's right here. So this is the solution to the inequality. You could check the others. Negative 5, 1, 2, 3, 4, 5, negative 2. That would put me here. So that would not work. And then 2, 0 is just right 2, which is just barely above that line, but that still does not work. All right, go ahead and try problem number 2 on your own. So the first thing you're going to want to do is solve to get that y all by itself. So first step is first put in slope-intercept form. Graph it. Graph and shade. And then figure out which one of those coordinates is in that shaded region. All right, for number 3, it says, which ordered pair is the solution to this linear inequality? And since there isn't a graph there, we can simply do some guessing and checking. We could always graph it, but we could always just plug in and check to see which one makes this inequality true. So what that means is when I put something in this left side for x or y, does that number I get when I actually do 2 times x minus 3 times y, is that number really less than 9? If it is a solution. If it's not, it is not a solution. So let's try A. So remember, x is our first coordinate and y is always the second. So where there's an x, I'll put the 6, and where there's the y, I'll put the -4. So I'm going to do 2 times 6 minus 3 times -4. All right, so that would be 12. -3 times -4 is positive 12, which makes 24. Is 24 less than 9? Absolutely not. So that is not a solution. All right, let's try the next one. 2 times -1. Again, remember this is the x and that's the y. So 2 times -1 minus 3 times y, which is -9. And we're checking to see if that's less than 9. So 2 times -1 is -2. -3 times -9 is a positive 27. So -2 plus 27 is 25. Is 25 less than 9? No. So that's also not a solution. All right, let's try C. Again, we'll plug 2 in for x and -5 in for y. So 2 times 2 minus 3 times -5. And we're checking, is that less than 9? So we're plugging those in up here, just so you know. Okay, so let's figure out what that is. So 2 times 2 is 4. -3 times -5 is a positive 15. 4 plus 15 is 19. Is 19 less than 9? No. So that does not make a true statement. So that is not a solution. All right, we better check this last one to see if it really works. So we're going to plug -3 in for x and -3 in for y. So 2 times -3 minus 3 times -3, is this less than 9? So 2 times -3 is -6. -3 times -3 is a positive 9. -6 plus 9 is 3. Is 3 less than 3? Oops, I just changed that to a 3. This was a 9. Duh. Is 3 less than 9? Yes, it is. So D is your answer. All right, so now go ahead and do the same thing for number 4. So let me actually start and do one of these with you. Let's do A together. So we're going to put -1 in for x and 5 in for y. All right, so here's my y on this one. And I'm plugging -1 in for the x. And we need to make sure that this makes a true statement. Okay, so let's see here. We have -2 times -1. That's a positive 2. Positive 2 plus 7 is 9. This is reading 5 is greater than or equal to 9. Is 5 bigger than 9? No, absolutely not. So this is not a solution. So now try B. If B doesn't work, try C, and so on. So it is a solution if it makes a true statement. So you're looking for this left side to be bigger than the right side. All right, number 5 says identify the ordered pairs that are solutions to the linear inequality. So you're going to check all of these, all 6 of them, just like we did on 3 and 4. I will tell you that instead of one of them being a solution, on this one there are 2 solutions. So you should end up with 2 check marks. So go ahead and plug your x coordinate in where x is and your y coordinate in where y is. And then if it makes a true solution, it is a solution. And I lied to you. I just saw that there's actually 3 solutions. So you should have 3 check marks there. 3 out of the 6 of those work. So go ahead and try that one now. All right, number 6 says, which ordered pair is in the solution set of the following system of inequalities? And we are going to go ahead and graph both of these. But remember, in order to graph, they need to be solved for y first, and they are not. So let's first solve 2x plus 4y is less than or equal to 12. So the first thing I would do is subtract that 2x and put it to the other side. Next thing I'll do is divide everything by 4. So we have y is less than or equal to negative 2 divided by 4 is negative 1/2 x, and 12 divided by 4 makes 3. So we can go ahead and graph this one. So we're going to start at 3 and put a dot. So go ahead and do this with me. Then we have to move our slope, which is negative 1/2. That means to go down 1 and right 2. Down 1, right 2. Or we could go up 1 and left 2. So you can always do the opposite. It is less than or equal to, which means I'm connecting these dots with a solid line. It's less than, which means I am shading below. All right, so that's our first one. Let's try the second one. So we'll do this one over here. 3x minus y is less than 2. I'm going to subtract 3x, put it on the other side. So I end up with negative y is less than negative 3x plus 2. Then I have to divide everything by negative 1. That'll make this a positive y. I divide it by a negative, so it's going to flip my sign. Then negative 3 divided by negative 1 gives me a positive 3x. 2 divided by negative 1 is negative 2. All right, so then we'll go ahead and start graphing this. So we're going to start at our negative 2 on the y-axis, and we'll move our slope. So since it just says 3, I can rewrite this as 3 over 1. So from this dot, I'm going to go up 3, right 1, up 3, right 1, up 3, right 1. Or I could go down 3 and left 1. This one is just greater than, so I am going to connect these with a dashed line. So remember, this line under here is what kind of is like a, hey, connect me with a solid line. There's a solid line under the inequality. When it's missing that, you connect it with a dashed line. Then I am greater than, so I have to shade on top of this line. So if I shaded on top of this line, it would go up here. Where my two colors intersect each other or overlap, this is my solution. Okay, so this part, just this part right here where my pink and blue overlap, this is my solution. Okay, solution. So now let's figure out which one of those coordinates is in there. So this first one says negative 3, 2. That would mean to go left 3, 1, 2, 3, and up 2. Look at that, it's right there. So that is in that green color I just shaded. So A is my solution. All right, go ahead and try number 7 on your own. Again, it says which ordered pair is in the solution set of the following system of inequalities. Those are already solved for y, so you can just start graphing. So that's kind of nice. So go ahead and try 7 on your own now. Go ahead and try number 8 on your own as well. It says which ordered pair is in the solution set of the following system of inequalities. So you're going to have to solve 3x plus 4y greater than 12 to get the y all by itself first, and then graph it. Then the second one is already in slope-intercept form, so you're good to go to just start graphing that. Then determine which one of these inequalities falls in your overlapped shaded region. So go ahead and try number 8 now. All right, now let's finish this last problem. It says which ordered pair is in the solution set of the following system of inequalities. This time you're going to graph y is less than or equal to 3x plus 1. That one we can go ahead and graph right away. right? It's already solved in slope-intercept form. Start at your 1 and then move your slope up 3, right 1. For x minus y is greater than 1, be sure to solve that to get the y by itself to start. Do not forget, when you multiply or divide by a negative, it does flip your inequality symbol. So go ahead and try number 9 on your own now.